Hello everyone, today I'm going to talk about the algorithms, how to implement the two-sums algorithm in Java. This kind of algorithm is frequently asked in interviews. The goal is not to only know the best solution, but to understand the data structure used. The two-sums problem is the following. I receive an array of numbers as input parameter, and as a second input parameter I receive a target value. The question is, find the two numbers in the array that sum the target value. In this kind of problem, I must always take into account the performance. I must make my solution as performant as possible, because they will test my solution against an array of thousands of elements. I will first write a simple solution, where I don't care about the performance, I only try to solve the problem. Then I will modify my solution to have a better performance. I will use LeetCode to test my solution. But before starting, remember to subscribe to my channel, please! Here is the method definition. I have the array and the target value. I must find two numbers in the array that sum the target value. What's the easiest way to test each element in the array? The for loop. Here I iterate over the complete list. I get the first element of the sum. Now I must look for the second element to obtain the target value. To make it easy, I iterate again over the array, but starting from I. And now I check if both numbers sum the target one. If that's the case, I return directly the solution. I don't continue iterating. The problem asks to return the indexes, not the values. So I return y and j. At the end I must return something. I return an empty value. That's it. Let's run the solution. Okay, I misspelled length. Let's run again. The solution is accepted. Let's submit it to see the performance. It works, but it's not good. Now it's time to optimize the code. What makes my solution slow is that there are two loops, one inside the other. This means that in the worst case, I iterate the array n squared. My solution has a big O of n squared. I use the first loop to iterate over all the elements in the array, and I use the second loop to search for a solution. So the second loop is a search system, but looking for a value one by one is not optimized. How can I improve this? Let's use another data structure, the hash map. A hash map is like a table where I can jump to a value with a key. I don't need to iterate all the table to know where is the entry. The concept here is that I associate a value to a key. How does it work? Java first creates an empty table, and it associates a key value for each row. When I receive a key, it uses a hash algorithm to transform my key into its key value. And now it knows which row to read and return the stored value. The main concept are the keys and the values. Internally, the hash map is a little bit more complicated. And you know what? The time complexity of a hash map to find an element is big O of 1. It doesn't matter how big is the map, it always takes the same time to find an element. Write in the comments if you want more details about how the hash map works. And now let's use the hash map to my solution. I first create my hash map. Map of integer map equals new hash map. The maps as the lists don't allow to use primitive types. That's why I use integers instead of ints. What do I store in this map? In the second loop, I'm looking for the complement value to sum the target. So the map will contain the complementary values as the keys and the index inside the array as the value, because that's what I must return. Let's see. I first calculate the complement, which is the target minus the first. And now I look into the map, it contains the key complement. If it contains, I return the result, which is I and map get complement, the value inside the map. But at first my map is empty. I can create another loop just before to initialize the map. I go from 2 loops, one inside the other, to 2 sequential loops. This makes my solution a big O of 2n. It's the same loop over all the list, over all the array, and I put the value and the index. But I can do it better. I have the same loop twice. If I didn't find the complement value, I store the current one. This is the condition where I look for the complement. If I don't find it, it's the else condition. And here I set the value into the map. So I can remove the first loop. Let's test the solution. It runs well. Let's now submit it to see the performance. A lot better now. When solving algorithm problems in the real life or interviews, I must always take into account the big O notation of my solution. There is always a search algorithm to implement, and I must find the best data structure to use in it. I will try to make more videos about how to solve algorithm problems. Only if this one works. So click on the like button, share it with your friends, add a comment and subscribe to my channel. Bye!